Hello everyone, and welcome back to another video. So here we have another graphics card. It's already completely disassembled and we have a multimeter here. So this is a diagnosis video, and depending on what we find, maybe even a repair video. So yeah, so this is an MSI TwinFrozr R9-280. I've been told there is nothing known about the issue of this. So the person I bought this from for 15 euros said they got the card from a friend as dead and they never bothered to diagnose it, so they just sold it on eBay instead. I already did a short visual inspection of the PCB and it looks mostly good except for this one corner, where you can see it is slightly bent. But there's not really anything in that area that could be damaged by the bending. So yeah. And then anything else, I can't really see anything. So we are just going to go into our normal troubleshooting process. And so first, we're going to set the multimeter into continuity mode. In other words, if we touch something with both our probes that is shorted together or like connected together with no resistance, it does this. So we're now going to check our power inputs. We have two power inputs here. One is 12 volts, one is 3.3 volts, and then we have our two power connectors here, which are both 12 volts. So we need to check every one of that for shorts. So we're going to connect one probe just to the I/O sheet because that is always grounded. And let's check the 12 volt on PCIe. That one is good. For 3.3 volt, we go 4 pins left. 1, 2, 3, 4. That one's also good. These connectors here are flipped, so they don't have the little connector thing on this side. It is on the back side. So the exposed pins we see here are actually 12 volts. This one is also good. A short beep can sometimes happen. And this one, also just a short beep. So our power inputs are actually okay. If we got a long continuous beep, that would have been a problem. So next we go into resistance mode. And we're going to check the output resistances of all our VRMs. So this card uses International Rectifier Direct FET, so we could just measure from the Direct FET directly, because this is an exposed metal part that is a conductor. But for the sake of having this also apply to other PCBs, we are just going to measure from the inductors. So these legs here from the inductors that stick through. Going to use the I/O sheet again. So first let's try our VDDC array, which powers our memory controller. That looks good. That, yeah, around like 30 ohms. I don't remember exactly what resistance you should expect here, but it is not suspiciously low. So I guess this resistance is okay. So these two upper phases, you can kind of see it in the power plane. Oh, there's a power plane here. This should be our memory power. And this also looks good. I have to say that this is an LPDA card. This is the first time I'm working with a 28 nanometer AMD card that does, well, it's actually the first time ever I'm working with an AMD card at all that is not based on Hynix memory. Depending on what brand of memory you have, your resistances can change. So if I remember correctly, this LPDA memory actually has a pretty high resistance to what I have in mind from from the Hynix memory modules. But this resistance is still okay. We're looking for something that's suspiciously low or very suspiciously high, and this is still well within range. Okay, let's try our core then. And that also looks mostly okay. It's actually a bit higher than I expected. I would be expecting more like 1 to 3 ohms. Maybe let's try a different ground point. Okay, where do we have a good ground point? Let's try one of the connectors here. The PCB can have some corrosion on it, which makes resistance measuring kind of hard. As you can see here, we're not getting a measurement at all. Can we just probe the ground side of one of these capacitors? Okay, 5 ohms. That should still be okay. It's still a bit higher than I expected. But 28 nanometer, like the smaller 28 nanometer cores actually do have some resistance to them. It's the very big cores that have pretty low resistance. And the Tahiti core is kind of right in the middle between a small and a bigger core. So a resistance of 5 ohms should be okay. So now when we have not detected any issues, we can turn the card on, because now we know that there's no obvious short anywhere and things are not gonna go on fire or explode. So I guess it's time to turn on the card, measure all the voltages, and then see if we can find an issue. It could totally be that this card just has a dead memory module or like a dead core on it, and all the VRMs are perfectly fine. That can be the case. But we'll see. We will see. So I guess I'm gonna clean this thermal paste off so I can hold my thumb to it to see how hot the card gets. And then we're gonna do some voltage measurements. Okay, we have the card in the test bench now. I have the other probe hooked up to the I/O chip back there, and we're gonna use this the positive probe to test our voltages. Thanks to this card having IR direct FETs, I can just probe the MOSFETs directly to get our voltages for the main rails. But before we do any of that, I'm just gonna test by just putting my hand on it if the core gets hot at home, because if not, we don't have to worry about it overheating, and we also directly know that our vCore power rail is not working. It does get hot, so we know that vCore is working. Let's wait a little bit and see if we get a picture. It's not gonna be on camera. You can kind of see the postcode. Okay, I'm not seeing a picture from this. Okay, let's turn it back off. There is a BIOS switch on this, so let's turn that once and see if that changes anything. It could just be a bad BIOS flash. But I'm more tending towards maybe a dead minor rail or some other major rail. Or maybe it was just posting kind of long. Let's see. You can see the postcode down there. Yeah, it gets pretty hot. So we get the graphics card debug LED on. I know, now it's off, but we still don't get a picture. Okay. Let's switch the BIOS switch back. Okay, so we can have a high confidence now that it's not just a... Well, it could still be memory corruption. Those don't give out an image, but I guess we can have high confidence that it's not just an artifact in core that just... Well, if it's the core, the only real fix would be to replace it. You can temporarily fix it with a heat gun, which I would probably do because this card was 15 euros and would probably end up as an e-power, so I might as well just get a few hours out of the core first. But anyway, so we're gonna test memory voltage first. 1.6 volts. Core, which we know is good, 1.2 volts. VDDCI, 850 millivolts. It got quite hot again. Okay, so the major rates work. VDDCI is a bit low, from what I remember. I think this should be at around 950. But this could totally be an idle thing. Because 850 should still be high enough to let the card start up. And it could totally be that it's just doing that when it's not under a lot of load to save power. Because this card is from around the era where more power saving features became popular. Okay, we have to get this fan away, because now I need to probe the PAX rail. If it's just a dead PAX rail, this is a pretty easy repair. So the PAX rail is on the back. Yeah. Nope, the PAX rail is running. Okay. So then, we have a low dropout regulator down there, and we have 2 low dropout regulators here. That should be basically everything else. Well, there's an inductor over here, but that's probably input filtering. Okay, let's take a closer look at the card again, to so we don't miss anything. So yeah. Oh, I also forgot this mine array, which could be 1.8 volts. But I do not know actually, because NVIDIA cards use 1.8 volt BIOS chips. But I think this should be 1.8. So we haven't tested this LDO, we haven't tested this array, and we haven't tested these 2 LDOs. We know that VCore is working, we know that memory is working, we know that VDDCI is working, and we know that the PEX array is running. So that leaves these 4 candidates, and then, well, this can really only be input filtering for the PCI Express slot. Here's our input filtering for the other power connectors. So, yeah. Because these are kind of hard to access, I'm going to get a riser cable and then test the card that way, so we have an easier time measuring there. Alright, so I have the card on a riser now. I couldn't find the very fancy one, so this will have to do. We only needed to give power to the PCI Express slot, so that is fine. So let's test our voltages. This one could actually be dead, depending on which pin is the output. No, this is working, this is 5 volts. And we need to shut the card down. Okay, so this is 5 volts. The middle pin was probably just ground, because this pin is at 5 volts and that's the output voltage. So this one is working. Let's test this little inductor, which I suspect is 1.8 volts next. Yep, that's 1.8 volts and it's working. Alright. Let's test these 2 LDOs over here as well. 12 volts, 3.8 volts, 12 volts, 4.8 volts. Okay. So these probably generate some voltages that support the 2 PWM controllers over here, or maybe the drivers. But yeah, we now have every single voltage rail running, which sadly means there's probably no electrical fault here, because everything is running as it's supposed to. But we're not getting an image, so we could have potentially memory corruption, where one or multiple of the memory chips are, well, corrupt and produce errors, and these errors could be so severe that we're not getting a picture at all. We could also have a problem with the core. That could totally be a thing, that maybe the memory controller is dead or there's other damage to the core. So what we're gonna try now is try to run mats on this. Oh, I actually don't know if that even works with AMD cards. Well, we're going to find out. I'm not sure if the edition I have works on AMD. It might be only NVIDIA. But I'm still going to try. And if it doesn't work, well, I'm gonna try a few more things to get it up and running. I had some issues before with PCI Express generations and different PCI Express slots. So maybe it was an issue like that all along, and the card was actually mostly fine, but it's a very low chance. And if everything else fails, I guess we are going to do what I always say you shouldn't do, and just give the card a heat gun treatment and see if it does something. Which I would never advise anyone who seriously thinks about repairing cards should do, because this card was very cheap, and it has a good VRM on it. If I can't get this card repaired, it will just become an e-power. And, well, when the card becomes an e-power, I don't care about what happens to the core and memory, so I can just heat gun it for a bit and then see if it works. But yeah. So I will try to run mats on the card now, see if that works out. And yeah, then we'll see what we can do next. So we have discovered some new things now. So I put a heatsink on the card in order to run mats on it, but now as you can see, we're not getting past the B2 postcode anymore, and our vCore has actually dropped. So the card boots up at 1.2 volts, but once it hits B2 it actually goes down to 950 millivolts, which is more in line with what I would expect the idle voltage to be. The thing is just, we are not getting past B2 anymore on any of the two BIOSes, which we did before. So this is a bit weird, honestly, but we have seen something like that before. With specifically, I can just show it. With this 7970 before it was modded. We also had there's also a diagnosis video for this one, and we did actually find something wrong with this, and I still haven't fixed that. You can see there is around the GPU there's a missing capacitor here, but the card actually works fine, but it was also getting stuck at B2 before, and the fix for this card was to just clean it. So we're not really getting past B2 here, and if we're not getting past B2 we can't boot onto our memory test USB stick. So yeah, we can still try using it in different PCI Express slots. Sometimes that does help, but I don't think it will help with getting past B2. So I'm gonna try some more things, and if that doesn't work, I guess I will just go ahead and clean the card. Also, if you remember, we had an HD7850 that seemingly also was completely okay from physical inspection and voltage checking, but it also just didn't put out an image. I don't know if it got stuck at B2, but cleaning that card also brought it back to working normally. So maybe this is just another candidate that just was neglected a bit. The PCB looks mostly fine, but there's some areas that have some dirt and what looks like could be corrosion on it. Maybe that is why the card is not working, because we have had several AMD cards, and I don't remember it happening to Nvidia cards, but I think there have been like 2 AMD cards now that just from cleaning them started working again. So there is a fairly high chance that this just needs to be cleaned. However, I do not know if I do not remember if the other cards also got stuck at B2. And this could mean a bigger issue. It could potentially mean that the BIOSes are corrupt, but both at the same time I think is very unlikely. We know that all the voltages are running correctly. So this could indicate maybe a problem with the core, which I hope it's not. But yeah, so I guess the next part would just be to just clean the card, get rid of all the dust and dirt and corrosion on it, and see if that changes anything. It's not gonna make things worse, at least. So yeah, but before I do that, I'm gonna try booting it in different PCI Express slots. I'm not really expecting to get anything out of that, but at least I can say I have tried it. So yeah, either the next clip is gonna be the card working somehow, or the next clip is gonna be the card getting washed, or more like you're just gonna see the card and it will be cleaned. Okay, until the next part then. Okay, here we are again. The card has been washed and dried, and here we are. So it's potentially the third card now that kind of just started working after being cleaned. I have to say to this though, I didn't want to wait the entire day for it to dry, so I did use the heat gun to get rid of all the water under the BGA. So like, when you wash a graphics card you tend to have water under your GPU and memory BGA. So I used the heat gun to get the water out of there, and yes, there was water under there, because like it came out of the side when I heated the card up. That could potentially have sort of accidentally thermoshocked the card. So yeah, I'm not entirely sure if it was like dirt or corrosion on something, we had that. We had that with the 7850, because that one I didn't heat gun. That one just generally started working after it got washed and dried naturally. So yeah, there is a chance that this was accidentally heat gunned. However, well, I didn't really apply the heat gun for very long. Not as long as I do when I actually try to thermoshock things. So yeah, the card works for now. I had a suspicion that that there was gonna be a dead memory chip, because it had all the telltale signs of memory corruption. I'm still in the process of downloading a test tool for the memory, because there is a chance that if this was just a heat gun, because when you heat gun things, it's a temporary fix. So this card might die again at some point if it was the heat gun that fixed it. If it was just some gunk on the PCB that went away when cleaned, this card is fully operational again. So I'm just gonna use it, I'm gonna use it for overclocking now. And depending on what happens, if the card dies again, I guess I will put it in the description, or maybe do a short video that I'm also gonna link in the description of this video, so you know what ultimately happened. And well, if the card just keeps working and nothing happens, I guess I'm not gonna bother making a video. But if you go down in the description and see, hey, the card did die, then we know it was probably just the heat gun. But at this point, I cannot really say what fixed the card, but based off that, we have a 7970 and an HD 7850, which are very similar cards to the R9-80, that did start working again after just being washed. I think there is a somewhat high chance that this just was some more dirt on the PCB, because these cards are just about old enough so that dirt and corrosion on the PCB can happen, and there was, specifically around the memory outputs, there was a bunch of dirt on the card that, well, I cleaned off now. It's pretty clean now. So yeah, I'm gonna write it down as cleaned and works again, but it might have been the heat gun. So if it dies again, I'm gonna let you know. But that is pretty much it for this video now. Yeah, so for now at least, the card works again, and it was a very unspectacular repair again. I'm always hoping for dead minor rails, or an obvious short circuit that you can repair by just replacing a MOSFET, because that's nice and easy and you actually get to show something. This, well, wasn't really a lot. At least we went through the troubleshooting process of checking resistances and voltages, and yeah. Anyway, so I hope you enjoyed watching this video, and until next time, goodbye.